Hi, good evening, everyone. Welcome to Google Developers Space channel, and thank you for tuning in to our live stream tonight. So today, we'll be having another episode of La Kopi. Yeah, I'm Lawrence from Google Developer Relations team, looking after our developer and startups community in the Southeast Asia region. So tonight, we have invited a Firebase expert. So it's a perfect opportunity for you to ask all your Firebase related questions. So feel free to leave your questions or comments in the live chat section. Okay, yeah. And before we start the session, I would like to do some advertisement. So before we go for our long holiday, we will have one more event. And tomorrow we'll be hosting Data Science Singapore and Tokopedia at 7 p.m. On Google Developer Space channel. So in case you missed out the event, you can actually subscribe to our YouTube channel and set a reminder. Yeah. So before we begin the session, so let me briefly introduce Google Developer Space and what we do. So Google Developer Space is a home for developers and startup from around the region to learn, connect, engage, and be inspired. We want to empower and connect the community to our people, network, programs, and technologies. So for Lakopi at Developer Space is a monthly event for developer community to learn, connect, and be inspired by each other. So every month, a tech team is selected, and developers will, share their knowledge and information with the community. So this month's theme is Firebase, and we will post the tech team on our social media channels, and you can reach out to us if you would like to share your projects. So please follow our social media channels to get the latest updates. So, yep. And like I say, this month's theme is Firebase, and we are glad to have Dennis tonight. So before I bring him up on stage, let me briefly introduce him, right? So Dennis is one of our Google developers expert for Firebase, and he's an active mentor for many Google startup programs. So he is also the CTO and founder of Oddbit, and Oddbit is a software development agency that focus on mobile and web app development. They also specialize in product development for startups too. Yeah. So now let me bring him out on stage so he can share more with all of you. Hi, Dennis.
Hi there.
Yeah, how are you today?
I'm doing pretty good. Uh,
Nice. Great. Yeah. So I guess I actually did a very brief introduction about you, and then maybe you can actually share more with the audience. Yeah, what you do and what Orbit is about. Yeah.
yeah, thank you. I heard the introduction earlier. So my name is Dennis. I'm originally from Sweden, but I'm living in Indonesia since 2009. So my background is in software development and with a master degree in computer science. So I'm the founder of Oddbit, and I'm currently functioning as a CTO of the team. And we started this company back in 2009, but it was run as a consultancy firm and me as a freelancer for a very long time. Until around 2017, we started to build a team around the company. And it was at the same time also that Google had recently acquired Firebase. And we thought it was a really great opportunity to try to get this involved with the professional work that they did together with clients. So since around 2017, we have been trying with more and more success to get this on with the clients that we're working with. And now I would say that there's a majority of the projects that we do are all using Firebase in one or another aspect.
Yeah, cool. Thanks so much. Yeah, so for everyone, for all of you who wants to find out more about Oddbit, I've actually pasted the website link in the comment section. So feel free to visit their website, and if you have any question, please connect with Dennis, and yeah, he will actually speak to you. Yep. So now, and let's begin our presentation. So if you have any questions for Dennis, please post it on the comments section. So we will address it after the presentation. So Dennis, let me bring up your slides, and you may begin your presentation.
All
Yep.
right, thank you. So tonight's topic is to demystify Firebase. And the reason I came up with this presentation is that it's kind of a frequently asked questions coming back from clients and new projects that we're starting. Or also when I've been doing some mentoring with Google for Startups, there's a certain amount of questions that keep coming back. And I was thinking, this is an opportunity for us to actually dig into this and structurize it in a way that is easier to present when the questions arise. So we're going to talk about a little bit of different things like cloud storage, Firestore, security rules, data modeling, and there will be a lot of post-it notes to keep this a little bit of a colorful presentation. So I'm thinking we're going to just jump straight into it, and let's hop on to the data modeling. One of the first things that comes up as questions when we work with documents databases is the data modeling. A lot of us as software engineers are coming from a background of SQL databases. We have done all this relational database modeling that we set up everything in tables and break it down to kind of remove redundancy of the data. And then for the first time, when we move into the document storage databases, there's a little bit of an aha moment, and it's a little bit of a shock to how we most effectively make use of its benefits. And redundancy is one thing that is the key concept that keeps coming up. For those who have been working with SQL databases, might recognize this query that we have on the left side. And I'm going to explain to you a little bit about the difference, how we do it in Firestore or document databases. So if, for example, we're having a user table in a SQL database, it's very easy for us to pick out certain columns or fields that we're interested in. So we can actually pack the user's table with all the information that is related to the user, as long as it's not repetitive. And then we just pick out those fields that we need in any query, for example, the photo, email, and name. In a document database, or at least in Firestore particularly, you can't cherry pick what are the information that you want to get out of that document. So when you query or when you retrieve a document, you're getting all the data, and you can't choose what parts of it that you're not going to take out. So this has the effect of it is that you might end up, if you don't carefully model your data, you might end up bloating the amount of data that you're downloading upon each query. So, for example, if you're having a user object that contains a lot of name, email, photo, last seen, maybe the latest post this user had been made, or you might have some password or anything like that in. For every retrieval of this user, you get all that data. And that might not be what you want all the time, because that means you can also see all this same data from any user that you're allowed to look at. For example, if I'm going to look at my friend's profile, I can download and get all the information that he can also see. So one of the ways that we usually do this in strategy of my company, at least, is that we separate the collections, and we make collections that contain smaller amount of data. This is also one of the frustrating moments of data modeling in Firestore that you might find on Stack Overflow when a lot of people are asking questions such as, what is the best way to model my data? In a document storage like this, the answer will a lot of the time be, well, it depends. And the explanation of the answer, well, it depends, is because we are modeling the data the way we need it in that use case. So to make that in a clear or maybe oversimplified way is to say you should have one collection of data for each view or for each use case you are having for that data. For example, if I would like to have a use case where I'm displaying the user's name with an email and just their photo, I'm not interested in having their bio or last seen or anything. This could be useful if, for example, if I'm allowed to see all of the other users on this platform. Then we could create a collection, for example, in this case, that's called users tiny. Then we have the main collection of users, which maybe only I'm allowed to look at my own user. I'm not allowed to look at any other users. For any change in this collection of, which could be our main collection of master data, we're using Cloud Functions, for example, on an onUpdate event, we're moving some parts of the data into this user's tiny collections, which only contains the relevant information for anyone to see. And this is this could optimize the use case, for example, for displaying all the users in a list. But since I have the ID, I can link to that user's full profile later on. So this would save me a lot of bandwidth instead of downloading the full user object if I'm going to list a lot of users. This could also be used in the case of, as I mentioned before, if you have a user's public. And this is something we have literally been using, for example, in blog publishing platforms when we've been building CMS. We want to have authors and we want to have an author's public collection, where the author's master collection might contain sensitive information, such as what are the roles they have, when were they last seen on the platform, etc. But for the public users who are looking into who are all the authors on the platform, they might only need to know what is their name, a picture of the user, and a short bio. And the same case is we do an onUpdate trigger that moves the relevant data that has changed into this public collection. So that means that if there are changes such as last seen, the user's public will not be updated if I just log into the platform and update the timestamp. There are also ways when you start with document storages that you may run into the problem of what happened to joins. One of the most powerful features of a relationship database is that we can do joins. We can take several tables and we can join in the data together to get out information in a way that's useful. In Firestore, you cannot make a join. So the way you have to work around it then is to duplicate the data. And this is often where a lot of, at least in my experience, when I'm coming from a relational database background, get a knee-jerk reaction because you go, oh, wait a minute, are we going to store the same data many times in several places? How do you maintain that? The reasons we do that is because Firestore is optimized for read. It so turns out that in most of the cases, you're reading data a magnitudes more often than you do writing the data. So we are paying the cost up front while where we are writing data. We're paying the cost up front to take the complexity of structuring the you could consider it as like a pre-joined collection of data. So for example, if we would have users and blog posts, we want to have blog post written by a user, and then we have another collection of users where we're maintaining the data separately. But then I might want to have another collection where I'm joining this information to say, I want to have information about the author and how many blog posts he has been writing. You could consider that to be a join in a relational database, but in a Firestore, we will duplicate the data. For example, you will see my ID, name, my photo, all of that data to be combined into the user's post statistics. And then I will take count the number of blog posts I have written and put it into the num posts field. So for every time I'm writing a new blog post, I will update that counter too. So whenever I need to display my statistics on my profile page, I will fetch from this collection that's called users post stats. So there is no join at the time of fetching the data, which is the difference of how you do it in a relational, in a SQL database, where you will do the join upon the time of reading the data. Here we do the join upon writing data. We already pre-calculate it and store it into a collection of itself. That will make the reads very fast. So another thing that is interesting to know about Firestore is how the indexing is working. You might have been hearing that Firestore has a constant read time regardless of the size of the database. What that means is that the time it takes to read 2 documents out of the database will perform equally fast in a database of 100 documents or 100 million documents. That itself is a mind-blowing fact, and I'm going to urge you to take me up on the word on that and check out the mathematics yourself behind it. But the reason this works is because Firestore is storing the data with adjacent in a sequence where the data is close to each other. So if you, for example, is fetching all the users living in Singapore, they will already have an index where all those user IDs are ordered by the country, where the country is alphabetically ordered. So you can fetch the first Singapore record and you can fetch it all the way down to where it's not Singapore anymore. And the performance of that will be regardless of how many documents were before and after in the database. So that means that the performance of the query will only depend on how many documents that your query retrieves. So if you would set in, for example, a limit of 2 documents, I only want to have these 2, then the query will perform equally fast all the time. But if you get more users and the result set becomes bigger in an unbound query like this, I might get more results that matches the condition Singapore. And that means that the query becomes slower and slower if the result set is growing bigger and bigger. But it's regardless of how much data is actually inside of the database itself. The nice thing with Firebase is also that you can do this composite. You don't need to make composite indexes in order to make this zip join. So as long as you do equality checks, such as get all the users that live in Indonesia and in the city of Denpasar. Firestore allows us to first fetch all the users that are ordered by Indonesia, and then we can also check zip join it with those who have the city of Denpasar. And this is actually quite performant regardless of how big the database gets. You can make a composite index for it if you want in order to optimize it further. But it's only if you're making inequality checks such as bigger than, smaller than, it's only then that you need to make composite indexes. And the reason for this is that if you're going to make a check, for example, this one is for inequality, where you say number of posts bigger than 20. So I want to get all the users that has the country that lives in Indonesia and have made more than 20 blog posts. We need to make a composite index because we need to create an index where we first order them by country, and then we attach to that also the second field, which is number of posts, and Firestore is going to order those 2 together for us. And for you who have been working with the real-time database in the past, you might know how it is recommended that you do this on your own. You're creating a path with data that is also kind of building a redundancy of data under that combination of the fields. So it's deliberately that I'm displaying it like this because it reminds you of how you would have stored it in the real-time database. There is a small quirk, though, with Firestore. If you come from a SQL database, you might be very flexible in how you want to query your data. You can say, give me all the users living in Indonesia. They made more than 10 blog posts and more than 3 comments. There is no problem doing this in a SQL database. But in Firestore, you can currently not do that. And the reason for this is that there is no easy way to both order a greater than, smaller than index for 2 different values. There's no way to combine it in any way that is easy to organize or even possible to organize. So right now, as of this talk, you cannot make this kind of query where you check both of those fields. How we've done it in our own field, though, is that we're making such a reasonable assumption that the secondary filter value will not be significantly making a significant impact of the number of data that we need to read. So in case we have this need that we need to sort out the users who made more than 3 comments, we would first fetch all the users who have made all the number of blog posts more than 10, and then we would make a secondary filtering inside of the client side of the application to throw away the data that doesn't match our secondary query requirement. This has the downside that we have already downloaded all of that data. So it means that we're paying for document reads that we later on didn't need in the client. It is a functional way of doing it, though. You should be critical to your strategy of doing this, because you might have another use case where there's a large amount of data that you need to throw away. It would be very costly for you if you follow me blindly on this advice, but take a look at, make an analysis of your data. You can use analytics platform or something like that to count, or you can use the performance monitoring that is built into Firebase to actually count how many rows of data are you throwing away when you do this secondary filtering. You can just put into the performance monitoring the amount of records you got first, and then you add to another counter to say we're throwing away this amount of documents, and you throw it into the perfmon, and later on you can analyze how is this performing for you. Does this work out well for you? You're going to pay a little bit of overhead, but it gives you the power to do filtering on 2 field values like this. I'm going to talk briefly about fetching strategies. And here's a little bit of a, we could argue back and forth whether this is, we're standing on, there's no rule of thumb of this being right or wrong. But I'm bringing up these 2 use cases where you're having live data, which could be, for example, a trading platform where you have stock tickers like this on the left side. Those kind of data is very much live, and we would like to see second by second how the value of the stock is performing, which ones are moving up and down. And you might expect the user experience might be better if you can see it updating in real time and moving around. There are other cases, though, and this is by default in Firestore. This is one of the powerful things that Firebase brought in, this real-time updates, that you don't need to send any push notifications to the client to say there's new data. In the past, it's been quite cumbersome on platforms before Firebase that you need to send like push notifications to the client and say there's new data. The client consumes the push notifications and make a pull from the database and updates the records that has been affected. What was powerful with Firebase is that all these updates coming real time directly pushed to the client. But in my experience, that doesn't mean we always need to do it that way. There are plenty of cases that you still want to do it the old way, where you just read data once and you leave it still in the client. And this would be, for example, if you're doing this blog post with comments, or you're having a movie application with reviews. In my opinion, the user experience might be quite weird if I'm currently reading someone's comment on the blog post or someone's review of the movie, and suddenly they're editing their review, and as I'm reading, it's disappearing or suddenly changing the text of it. You might want to use Firebase in these cases to just make a single-time fetch. You just take the data, you fetch it, and you place it, and you don't subscribe to the live data. The downside of this will be, though, that you can't utilize this smart cache that is progressively only updating documents that has been changed. You might be paying for a few more document reads, but depending on your user experience, it might make more sense for the user to look at data that doesn't change like a Google Doc does as they are reading it. Again, it comes back to the frustrating answer, well, it depends. Pagination can be done in Firestore too, where you're using result set or a query to tell Firestore where was the last entry point where you stopped. If you set a limit of 5 documents, you can tell Firestore start after the 5th document. This is the document reference where I would like to fetch the remaining data. For you who have been working with pagination or like start at, start after in your queries, you might know that it can sometimes be quite complex or difficult to implement it. There is another way where you actually can just use the limit with an increasing limit to get data at an ever-increasing number. And this would be, for example, if again, you're having your blog post with the comments and you first display the 5 first comments on the blog post, which is most likely people will be reading. And as the user scrolls downward with your infinite scroll, you want to fetch another 10 to make a total of 15. there is a tip for you here that you can actually just use limits to increase the limit, to just say, you know what, take all the comments for this blog post, limit by 5. Next time you start scrolling, you make the same query again, limit by 15. As they keep scrolling, you limit by 50, 75, 100, etc. The good thing about this is it's super simple to implement. The downside with it, though, is it will cost you more. You're going to have to pay for these same document reads over and over and over. For every increment, you keep paying for the documents that you actually already read. So that's the downside of it. But if you're going to do something very quick, maybe it's very seldom anyone scrolls further down than the first 5 or 15 documents, you could give it a shot. You implement it in 5 minutes instead of maybe an hour or something like that, to just have it a try. Again, use the performance monitoring to measure how it performs for you, and you make a decision whether this is the best strategy or if it's going to cost you more. Gonna take a little bit of a tour into the rules, and for you who have been working with Firestore might also recognize this, which is the starting rule set that you get when you create a new database. Firestore Rules has removed the need to have any API, like, how do you say it, border between your database and the client. Normally we do the authentication authorization within this API layer to say where to check who is this user making the request, what kind of roles and permissions are they having in the database, in order to figure out what is the data they are allowed to retrieve from the database. It might come like a small shock to some people, at least it did for me. The first time you work with Firestore, you realize that the users are having direct access to your database, and we are just declaring the rules of access here in this language that Firebase has created. It still turns out that it's actually very complete to do this. So when you start up the database, you will see that match all the documents with this wildcard and read and write false. That means that your whole database is locked down from any reading or access of data. So now you can actually publish your application out in the wild, and no client is allowed to access any data anywhere in your database. It's very secure, very useless. So anything that is not explicitly allowed is disallowed. But you got to be careful with the wildcards. Once you turn that conditional around and say it's true, you might get unexpected effects. You might give your users access to read data that you didn't intend to do. So what you should do instead is to explicitly show what is the data that is allowed to read under what conditions. In the case of the blog post and the users, we would say match the collection of blog with any ID. We are allowed to read it if we are logged in. Request.out not equals null would translate into the user has been logging into our platform. We could also say match the collection of users and any UID. You're allowed to read and write it if your UID that you're authenticated as is equal to the UID which matches the document ID. So in this case, we would create a document ID which has the same ID as my current user ID from the authorization object. And under there, I store all my username, email, last login, etc. This rule would allow me to read and write my own user, but I can't query or check any of the other users. But hey, that was a lot, right? We want to reuse this information, so break it out into functions because functions are great. Luckily, you can declare functions also in the rules language of Firestore. So you just put it down in the bottom and you call it is signed in. And then in that function, you check request auth is not null. And then I can use it further up in my rules and say, you're allowed to read any blog post if you're signed in. Now your rules become much easier to read And the more easy it is to read something, generally, the more secure it becomes, because now the auditing, visual auditing, will become much easier for someone who is reviewing your code. And for the same thing for users, you can see allow read and write if I'm signed in as the UID. And you can reuse these wildcards that you see inside of the parentheses UID. You can use them as parameters to pass into your functions too. So you can see I use it further down in the function declaration is signed in as UID, and then I check the request auth UID. You can split, you can update your rule to restrict creating and deleting. For example, I might want to restrict that you're only allowed to update your documents. This was slightly weird. It should be create, update probably. But maybe I want to prevent the users from deleting any documents in the database. It might be, for example, also that you don't want anyone to accidentally or maliciously delete their own users, which might render your data inconsistent. So sometimes we're actually removing the delete access to documents. Instead, we're flagging them as delete because it might create inconsistency in relation between documents. So in this case, we say the blog with the ID, you're allowed to read it if you're signed in, and you're allowed to update it if you're signed in as the author of the document itself. And the resource.data refers to the document as it was before anything changed. There is another built-in set that you can say request.resource.data. That is the data that will be written after the update has succeeded. But in this case, I say you're allowed to update if the current state of the document says that you are the author. And that would mean that I'm not allowed to change who is the author of the object, right? Because if I'm trying to change, I cannot push the new author and try to override it like that. And if you start nesting the data with sub-collection, the rules does not cascade. Remember what I said in the beginning with the wildcards? Be careful with wildcards, because if you place a wildcard rule higher up in your rules hierarchy, that one will allow anything that follows below too. So if it's not explicitly allowed, it's disallowed in Firestore. And the rules does not cascade. So in this case, if I have a revisions sub-collection to each blog post, I declare a rule further down and say you're allowed to read blog ID if you're signed in, and you're allowed to update it if you're signed in as the author. But if I didn't declare this revisions matching rule here, you wouldn't be allowed to read the revisions. So I need to explicitly say, and if you want to read the revisions, you need to also be signed in. And this is, for me, recommended to do this because you're more in control. And if you add further sub-collections to your blog collection, you're not running into a problem where you're accidentally giving access to users who are not supposed to have it. So be explicit once you go into production. During development, sometimes it happens we use the wildcards, but as soon as we go to production, we remove wildcards and we explicitly point out each sub-collection and collection and what are the rules and conditions that users are allowed to access those. Doing that, you don't accidentally refactor or add some data that accidentally starts leaking. The nice thing with this hierarchy of collections and sub-collections is that you can also reuse these ID wildcards further down in your rule set. For example, you can say a revision is allowed to be created if you're signed in as the author and the data is containing the original ID of the data is the same as the one that matches the blog, which means that I cannot create revisions of my blog post that is not having the same ID as the original blog post. And I touched this earlier before, that you have some different, you have request.data.author and resource.data.author. That means that the request.data contains the data as it will be after change. And the update contains the data as it was before the change. So the change has not applied yet at the time when we are inspecting the rules. Instead, we are checking to make sure that the rules are sane before and after. And the resource.data, the request.data says that this is the data I would like to create or update or write to the database. So I can access that data and inspect it to make sure that before anything changes, I would like to inspect and make a sanity check on it. So this would, for example, say that you're only allowed to create a blog post if you assign yourself as the author. And you're only allowed to update the blog post if you already were the author. This will prevent anyone from editing anyone else's blog post. And it's as simple as that. And like I mentioned before, in this case, we don't have a rule that allows the user to delete any data. So what you can do is, for example, to say research.data is deleted. You're allowed to read the data if it's not deleted already. And you're allowed to update the data if it's not marked as deleted. This means that we don't have any rule, we don't have any delete access to the database. And we are also, in this case, not removing any documents from the collection. Instead, we are marking them as is deleted equals true. And the rule saying you're only allowed to read it if deleted equals false. So that means that if I would switch that Boolean in any document to say that this document is deleted, that rule on read access would not allow me to read that document. So there's an important thing to understand here is that Firestore does not filter out data. So you can't be smart here and say, oh, I'm going to fetch all the data and I'm going to see what Firestore omitted from it. The thing with Firestore rules is that they are validating your query. If you have a rule saying that you're only allowed to read the data if the data has a flag equals to false, that means your query needs to include that condition and said, I would like to fetch documents where is deleted equals false. If you would change that to fetch everything from the blog where is deleted equals true, the validation of your query would fail because you have declared in the rules that you must make a query where you check the condition to be equal to false. Also, if you would omit this field to check, the rules inspection would fail because you did not declare what is the value you want to have on the is deleted field. This is a very smart way because then you can check whether your queries are sane before you're even making them. All right. So with that, my time is out. So I'm going to say thank you. You can find me on Twitter and GitHub at Dennis Alund.
Cool. Thank you so much, Dennis. Yeah, there's a lot of information from your presentation. Yeah, so before we end this session, right? So we have some questions for you. So some of them actually are from the audience attendees actually send the question to us. Yeah. So one of them is this like do we need to create like composite indexes before we can query against multiple fields?
No, if you are doing equality checks, you don't need to make any composite indexes. You only need to make the composite indexes if you're doing the non-equality, meaning that range queries such as is bigger than or is smaller than, because then you need to combine in the range, how to order that data also. But as long as you're doing equality checks such as is country equals Indonesia, is the city equals Denpasar, is the name equals Dennis, then Firestore helps us to make a zip join where it first takes the first result set, it checks against the next index and try to filter out those that doesn't match and to the next one. And the performance of that is quite good already. So you don't need to make composite indexes as long as you just use the equality comparison.
Cool. Thanks. Hope the answer actually answers the questions. Yeah. So there's an actually next question. So suppose fetching documents triggers the security rule to check the contents of the documents. If the rule is considered to fail, does it still count towards the read quota?
No, because the SDK will check your query upon the time of querying. So if your query is how do you say it? It's not if your query is not validating correctly towards your rule set, if it's offensive towards missing out on any check or making an invalid comparison in your query, it will fail already on the validation. So you don't actually need to round trip it to test that.
Okay, cool. We have two more questions. The other one is how can we do an equivalent of inner join on Firebase when fetching documents?
Okay, yeah. So this is the trick one, right? And this is a struggle often for people coming from relational databases or SQL databases into document stores like Firestore, is that it feels very awkward and stiff. And I've seen in the past also many they are fetching data from many collections and joining it in the client. But you can actually make a pre-joined collection. There's nothing bad. It's even recommended that you duplicate your data. So if you know you have a use case where a lot of some of the data is very often joined together, for example, if a user is having many addresses and you're maintaining this differently, you can make a collection that you call user addresses, and you maintain the source collection separately for two pieces of data. And when any of those change, you put them into this middle document, this middle collection, which is a pre-baked version of that data. And that will speed up your read time very much, because the cost of storing the data is much cheaper than the cost of reading two different data and joining them afterwards.
Cool. Thanks for the answer. Yep. And one last question. So, is there any no tricks or tips on how to reduce the cost of Firebase?
Yeah, reducing the cost of Firebase. That is you can get into a few, use a development project separately from your production project where you have a smaller set of data. It will give you a little bit of an indication how much it's costing. You can do cost profiling, for example, for if you have 10 test users, you can do a little bit of cost profiling. What does each user cost, to get an idea later on when we scale this up to 1,000, 10,000, and 100,000. At the worst case, it should just multiply by that. In the best case, it might get cheaper because you might pay for less. Maybe the spin up time of your cloud functions might be slight, or it might be higher performance. But reducing the cost, we're doing a lot of profiling, and we're using also the performance monitoring to count the number of documents we are reading. And there was another case where I said we are sometimes counting how many documents do we throw away. If we, for example, fetching a big piece of data from Firestore, and then we have internal filtering in the client where they may be having some click filters where they do filter out only stores that are open right now. We might fetch all the stores first and throw away those that are closed. And you can use performance monitoring to count the amount of data that you threw away there, because you're going to still pay for the document reads, even though you didn't display them for the client, perhaps. So performance monitoring is a good tool to also put in a little bit where you're suspecting you could squeeze a little bit. Otherwise, ways to reduce the cost. Be careful with how often you're updating and writing documents, because it's much more expensive to write or update a document than it is to read it. So that would probably be a tip. It's a little bit hard. It's a very generic question. Thank you. It's be
Yeah,
careful.
I think it is very generic. Yeah, and Henry, thanks for sharing the tips. Yeah, I believe that every project is different, so we have to examine each project individually and then look at how it works, right? Yeah. So one comment coming from the audience is that, can I get Dennis' autograph? Yes, you can.
Yeah. Wait,
Yeah.
wait.
So please
There you
connect.
go.
Yeah. Yeah. Please connect with Dennis, and then you can get it from him. Okay. Cool. Thank you so much, Dennis. Thank you so much for sharing all this information. It's actually very useful to all the audience. Yep. So thank you so much, and then we'll see you again. Yeah. Now I'll bring you off stage first. Okay. Yeah. Thank
Okay.
you. See you.
Thank
See
you.
you
Good night,
again.
everyone.
Yep. So hi everyone. So that's the end of the session. So if you actually liked our content, please stay connected with us by signing up our mailing list on our website, or follow us on our social medias. Okay. And then we actually value your feedback very much. So please scan a QR code or go to the link below, and then give us your comments. And then we'd like to hear more so we can actually improve on that. Yeah. So yeah, thank you so much for your time, and stay tuned for our upcoming events on our website and social media. So looking forward to see you again. Okay, good night, everyone.